So as we talked about last week, we're going to be looking at a number of different things concerning classes and objects. Earlier this week, we talked about the this reference, how it's used in your classes, and referencing objects and so forth. One of the things we didn't cover is the this reference is not needed um, uh, in most situations. You can't use it, in fact, to reference. Let's see. Let me pull this up here where I'm at. We'll use it on variables and methods. This represents the class as a whole itself. You do not have to use this on static fields. Static fields are, remember, they are instances of the class available through the class and not in the object. So let me close this what I have here for a moment. And let's talk about, we talked about final keyword. Let's see here. All right, so I'm going to create a simple project here. And the purpose of this project is just to demonstrate memory references using static. Okay. So we'll just call this test static variables, just for our own references. All right. I'm going to create a public static string, and we'll call the string my word, and it equals, in all caps, word. So this variable in itself right now, the question is, can it be modified? If we do system out, let's declare a new variable and just call this string copy of my word equals my word. Now, what that tells you is that you can make a copy of the my word. And if we system out print line it, we'll see that copy of my word you can see the actual word itself. So this shows that you can copy the word, but you haven't actually changed the reference, the memory reference to my word. So now let's take my word equals, and you notice right away it's starting to complain, or at least we think it is. So now we're changing the static reference to my word inside the main method. So we have system out print line, my word, we'll run it again. And there it is. Remember that when we declare something static, it is available at the class level. You don't have to create an instance of it. And in a way, what we did here is we created an instance of my word, right? And then we overrode it. The other way this can work as well is through something like this: public static void change my word string MW, for short, my word, and we're going to say let's just take system out print line MW. All right. So we'll come back up here. We're going to call change my word. We're going to pass my word reference. And the question in the textbook was, can we do this? And if you remember, our PowerPoint slides say that you can't use the this reference on a static because my word is not an object. It's a part of the class. So if we tried to run this, passing this dot my word, we're going to get an error. And again, a non-static variable, this cannot be referenced from a static context. So what we can do is we can say main, because my word is it's a static variable of the class main. Did someone just come in late? Jim? All right, let me make sure I get you counted real quick. Has anyone else came in late? We're looking for Mike, and that's it. Mike's not here yet. Okay. All right. So we can use main because main is the class name, right? Anytime we declare something static, we can say my word. We can also do this. We can say main, and we can access the public static method because the method is attached to the class. You don't have to instantiate an object to get access to that method, right? Okay, so let's go down here. Let's just keep it simple for a moment. We're just going to pass in my word into change my word, and right now it's not doing anything, right? It's just a reference to the value, and it's going to print it out. And as you can see, it just printed it out. But it's printed out the change here. So for our own purposes, let's take that out. Remove that one. We're going to come down to change my word, and we're going to say my word equals MW. Or better yet, you really don't have to worry about that because you've taken this value and it's static, right? So you're just changing the reference to it down here. But how do we protect values from being changed inside the method? Say we don't want this variable to change. How do we do that? What keyword? Final. So now, if I come in here and I try to say MW equals MW, what does it tell me? Cannot assign a value to MW. So I'm taking MW and I'm just assigning it to itself. Final protects us from that. It keeps us from changing values. Now, this begs the question, when do you want to use final? When do you want to make the parameter going into a method final? Well, maybe it's a value that you don't want changed, right? Like a person's name. If I put John in, I don't want to get out Winnie, right? In assignment 10, yes? Okay. But in this case, anytime we put final, that's what that means. All right. So this is working with the static. All right. So let's put this on pause for a second. We're testing static variables. We'll go ahead and use the same class for a moment. You all should have done your discussion forum for this week. What was it that you learned about constants and pre-written constants? Anyone like to share? You guys did do it, right? Yes. Okay. So what did you learn about constants in general, the pre-written constants? So we have math, what is it? Java, Lang, math, dot, is it pi? What is that reference? Do you guys remember? What is the reference to pi? I can barely see your screen from over here, Chris. I'm shoulder surfing with you. Yeah. Yeah. So let's take a look here. I got my textbook open, and okay, Java Lang, there it is, Java Lang Math Pi, right? So Java Lang Math dot pi. And this may be because I'm using I am. Okay, hang on one second. Yeah, that's why. Excuse the man behind the curtains as he redoes his. All right, so I create a new class here. All right. Okay. Constants are one of those things that you guys are going to write a lot of, by the way. You're going to find that there are certain variables that you're going to repeat all the time. And maybe it's the company's name or an address, or maybe it's a value in your code that you find yourself having to use over and over and over and over again. Those are great places for constants. Sometimes, though, other constants, it's kind of valuable to use them, like math dot pi, right? So here I have pi, and if I system out printline it, we can see that what that constant is. By the way, in IntelliJ, I've showed you this as well. You can control click on variables, and IntelliJ will decompile those classes and give you read-only versions of them, so you can inspect and see how they did it. So here we can see that it spits out what pi is. If I wanted to see what that was by looking into it, I could control click and I could see that they've typed out public static final double pi. So the static means that the variable is available from the class, hence math.pi. I can just call it just like that. But final means that I can't change it. Now to validate this, we could say my pi equals a new number. Is that valid? This is a trick question. What do you think? Remember that a memory reference, a variable, once I declare it, it's a memory reference. It's a brand new memory reference. And so this right here, this math.pi, is a memory reference. It exists in memory. And so does this. It's now a memory reference. And because I haven't declared it final, I could change it. As soon as I declare it final, I can't change the pi, right? And so if I come over here and I try to say math.pi equals, I can't do that either because pi is a final variable, right? This is the power of having constants. They're protected. There's something you don't have to worry about. All right. So those are some of the constants, but you also have these other great variables that you could use, math methods. For example, you could say math dot, I want the floor of some number, and let's pass in my fake pi. And if I do that, the floor, and if you hover over this, it tells you what it's going to, well, let's just control click into it to see the Java doc. Remember what I said before, this is the Java doc, this comment about the code. It returns the largest closest to positive infinity. So the value that is less than or equal to the argument and equal to the mathematical integer. So the largest closable positive infinity, a floating point value less than or equal to the argument that's equal to the mathematical integer. So if I pass in 0.8888 and we spit this out, it will return 0. So the best way to describe floor is the bottom of that decimal number. So the bottom of that decimal number is 0 point. So the floor is 0. If I passed in a 1, it'll give me 1. But here's a more interesting way to do this. Say I just pass in math.pi. It's going to question for you before we do this. Math.pi, is it going to change the memory location, or is it going to spit out a new memory location for math.pi? You guys are like, I have no idea. All right. It will be a new memory location in a sense because floor returns a value. And so I'm taking a value and passing it in. I'm changing that value internally and spitting it out. It's a new memory location. And so anyways, if I run floor on pi, it should give me what number? On math.pi. Gives you a 3, right? So there are all these really useful, for example, you could do random. And let's say my number random is, it's a number between 0.0 and 1.0. And to prove that, we'll system out print line it. So you can see what it will spit out. And that will give you some random decimal number, right? So here's the question. How do I get a positive number from that? Well, how big of a decimal place move do I want to make? All right, so I'm moving it by 1 decimal point, right? So in the tens category. So let's do our system out print line. I'm going to say 10 times math.random, and that should now give me a positive number, but it'll still have a decimal. You guys understand? It'll be some number, an integer. Maybe I didn't multiply it high enough. Did I do that right? What's funny is I'm recording this and it's going on YouTube, and I'm sure some programmer out there is going to watch this and go, wrong! Thumbs down! All right. So remember, math.random it's a random number. So it's going to generate a random number. Maybe it was just it generated a 0. Maybe it generated 0. So maybe I have to run it again. There we go. 6. That's the thing when you're working with random. You never... I did it correct the first time, but it gave me a 0, which is, yeah, 0 between 0 and, right? So to demonstrate, let's do it like this. For int I equals 0, I is less than or equal to 10, I plus plus. All right, you haven't got into for loops yet, but this is a foretaste. Now we can see that it should have spit out this random number 10 times. Of course, minus this first one because, yeah. So let's, just so we can see it, let's do it like this. Let's do I plus, got to do string literal here because otherwise it'll add I to the random number. Okay. Some people make that mistake. Oh, I'm just going to just append. Nope. Got to put those string literals in. Otherwise, you're going to get some strange results. So I got a string literal saying, pointing over to this direction. Okay. So we'll run it again so you can see that it ran 10 times. There you go. It actually ran more than 10 times because I is less than or equal to 10, and I started at 0, so that's 11 times. Make sense? All right. So there's math.random. But let's say we want to take it further. We have math.random, and we don't want the digits. We want just the integer, just a random number, right? We don't care about all that other gobbledygook. All right, so we'd say math.floor, wrap the results, right? Or should I put it somewhere else? What's going to happen if I do math.floor at this level? Floor always gives me the integer. And if random is a number between 0 and 1, it's always going to give me either a 0 and 1 times 10, which is not really random, right? So what we want to do is we want to move this inside of there. Does that make sense? All right, so now we'll run it again. And now we have a random number, 5, 1, 6, 8, right? And let's say we wanted 18 random numbers. There we go. I is less than 18. Stop. There we go. So now, when you run it, I have 18 numbers, even though it starts at 0, right? And they're random. They don't repeat. They're just randomly generated. Okay, so that's using math.random. And let's say that you instead want to make this even more interesting. and you want to say math.round. So now this is going to produce some not necessarily the same results as floor, right? Because round means from 5.5 up, it's going to be the next number. If it's 4 down, it'll be the lowest number, right? So if I run it like that, of course you can't really see because it's always generating a random number. But now we have just the integer being spit out, which is closer to what you guys might want to see with a non-decimal. The other route you could go is ceiling. And what do you think ceiling does opposed to random and floor? Ceiling gives you automatically the next number up. So let's just put an example over here just so you can see it. System out print line, math dot ceiling. I'm going to pass in a let's say 8.2. All right. So what do you think it's going to pass in? What do you think it'll print out if it's ceiling? 9, exactly. 9. So we'll print it out here and you can see the number that it puts out. And there's 9. So that's math.ceiling. Then you get into other things like sine, cosine, tangent. Fun stuff, right? It's like, yes, I wish I had this when I was in my... What do you use sine and cosine for? Algebra, trigonometry. All right. But here's another interesting one. Let's throw in, let's say it is the math dot square root of 8.2. What is that going to generate? Let me just put this up here so we can see it. So math.square root of 8.2 is going to give you square root of 8.2 is this bizarre number, right? But if I do something like what, 16? No, let's do a better one. Let's do 25, right? What do you think? Is that a good one to use? Yeah. There you go. All right, so these are the math classes. There's a bunch of them. All right. Everything that is Java Lang, you get for free. I did not have to come up here and type import java.lang to access these. Everything in the Lang package you get for free. All right, they come available. If you wanted to get everything in the math package, then you could do that normally. But you don't have to because everything comes for free. String exists in the java.lang. You don't have to import it. It's already there for free. Other things that are already there are the wrapper class like integer. Automatically available. You get it for free. And if you're curious about all the other packages, sub-packages that are there, you have a bunch. You have annotation, instrument, invoke, management, module, ref, reflection. Yeah. And you can see that there's a bunch more. Other things that are important like exception, runnable, runtime exception, runtime. All of those are important as well. They have to be available in the Lang package because they're needed for the Java programming language to run. Okay, let's take a look here. So let's say that you have a class that you want to import that's not available for free. Believe it or not, you've already done some of this because you have been importing things like javax dot swing dot, right? All of these other packages. And this is how you import something. If you do the asterisk, that tells you give me everything at that package level. What a package level is a folder. So if I have basically javax.swing starts out with a folder called javax, and inside of that there is a folder called swing, and inside of that there is a folder called border. But at the swing level, there's also all of these other classes. So when you do a wildcard include, you're saying give me everything at this package level, all of the classes. The wildcard does not give you the next package level. Okay? So it only gives you the current package level, the classes, the interfaces, the enumerations, and so forth. All right. Does that make sense? All right. Okay, now we get into something fun. I'm going to create a new class for this. Back when I started programming, we did not have the local date class. We had just date. And it was painful. So the local date class, and by the way, you can do this local date, and you can see the package in IntelliJ. It'll tell you. If you hit enter while that's selected, it should automatically include the import up here for you. Okay, just a little helpful tool. But if you don't do the include, you're going to have to type java.time.localDate. Okay, local date has some very interesting properties to it. Local date gives you a date that is local. These guys are geniuses with their names, right? You're going to find though some geeks and nerds, they like to name their projects these strange names. Like a version of Linux is called Red Hat. Yeah, it's kind of like, why? Or they'll, the symbol for Linux is a penguin, right? In Java, we have lots of creative names. For example, we have an application server called Glassfish. Glassfish, yes. We have JBoss makes an application server called Wildfly. Yeah, it's like, okay, where do they come up with these names? Apache, their most common application server is called Tomcat. So, yeah. Anyways, local date, let me get back on task here. So I'm going to create a local date, and I'm going to call it now. Or be more specific, I'll call it today equals, and this is where it gets strange. This is going to be your first delve into using a class that doesn't have a public constructor. Because you cannot do this. Local date. The reason is there is no public constructor. And because there's no public constructor, you can't instantiate an instance of local date using new local date. Yeah. What they've done is they've created a public static method, though, in the class. And these methods, they give you the instance of the date. And so that's how you get today. All right, so I'm going to take this and copy it into my public static main method. today, let me back up. Local date, just like all Java classes, extends from the object class. And in the object class, you get for free a method called toString. So when you do something like system out println today, it will print. In fact, every class you write will print. It just may not give you the desired results. This one is designed to print, to output a date in the format of year-month-day. All right, so we'll print it so you can see that. And you can see that it is printed out the year, the month, and the day. If I want to create a local date, but I don't want my date to be today, I want it to be yesterday, I can say local date of, and it's going to take several parameters. The first one is an integer of 2020, and then I'm going to, actually let me make sure here. Int, month, int. Yes, okay. So 2020, and then I could pass in a month. Now the standard enumeration for a month is what? What month were you born? Give me the number. 5, right? Who was born in July? Who's a July baby? You guys rock. All right. This is nice. Local date is nice because they use the standard numbering. You're going to find later in Java that some things don't use standard numbering. They use a zero base instance. So local date uses the starting point of 1 for January. If you use the old-fashioned date object, the date object uses 0 for January, 1 for February, 2, and that gets confusing. Yeah. So they did something nice for us because we all understand months to be, a day. All right, so we'll go with 5. And then the day of the month is 1. And if I print this out, you can see that yesterday is not actually the 5th of the month, but you can see that how you set a date object. And so there's the value, the date object that we set. The local date also has a nice feature. You can say local date of, and you can see that it also gives you this month syntax. So we can say 2020, and we can say, IntelliJ is being nice to me. It's already looking ahead, but let's just type in month, and it gives me all of these months. So I'm just going to say October, and the day of the month, is there a day? No, there's not. I'll just say 2. All right, we'll print this out. If I can type. We have to assign it first. Let's assign it. Long time ago. And that doesn't make sense for that, so we'll just say 0 for the year 2000. Okay, so now I have my date long time ago, and let's use print line, not print format. Okay, we print it out, and it gives us, there's the date. All right. The local date is very important to use. I recommend that you learn how to use it. It's powerful. It makes it very easy. There is a number of other things you can do with local date. There is what's called the now. You can also pass in a clock object, a zone ID. So for example, if you know the zone ID, let's play around with that one for a second. Let's say local date. Let's see. Anyone for Korea in here? Korea date. Just local date of what was I looking at? Here it is. Zone ID. So we have a zone ID, and let's see if they give us. Oh, they don't. All right. Let's drill into the class. This is the nice thing about drilling into a class. You can kind of get an idea. Okay, here we go. These are the zone IDs. So we can say, is there one for Korea? It's Karachi. It's Ho Chi Minh. Is there a Seoul? No? Wow. All right, well, let's pick a different one. How about Beijing? Did I spell it wrong? Shanghai? There it is. All right, CTT. All right. So the zone ID and then you pass in the value. All right. I should probably call this Shanghai, right? I'm going to be honest, I don't know how to spell this. Uh-huh. H-A-I. Okay. Thank you so much. All right. So this is S-H-A-N-G-H-A-I. And what am I missing out here? Oh, I made it caps. I shouldn't have done that. There we go. All right, so let's see what it prints out. I have no idea what it'll print out. What time it is in Shanghai right now? And we got an error. It's unknown time zone, CTT. All right, so we probably didn't use the correct reference. So that's the key value. Did I do it right? CTT? CTT. Maybe it's this. Hey, there we go. And it's about the same time in Shanghai right now. Okay, so those are some different examples. The other things that you have in here, for example, are epoch. And that gives you the start of when we started recording time according to Java, which is 1970. Which is not when we started recording time, but as far as computers are going, what they do, this is based on the old way of milliseconds are counted up since 1970. And so if you do something like date, there's a millisecond time. But anyway, the milliseconds is it's a long number. meaning it's of type long, not that it is a long number too. It's type long, and it's just this big number that's counted all the way back from 1970. That's the epoch. Okay. What else do we have here about this class? I want to show you one other thing real quick though. So if we look at the local date, you see that this is how they're creating. It's a public static local dates with the returning. The method's called now. If you drill down into it, you're finally going to get to a place where they actually create the local date. But you got to drill way down to it. It's down here somewhere. There it is. So local date, this is the constructor. It's private. And so the reason they do this is because they have a lot of logic that controls how that object should be created. And they want you to use the method, the predefined methods. So when you're creating an object, if you write a class and you have a special way that class you want it to be created, you could make your constructor private, but you just need to make sure that you provide the right way of doing it. The other thing you're going to notice about the local date class is it's final. We haven't talked about this yet, and you will. Final basically means that it can't be changed, right? So final means that you can't extend from it when it's on a class. So if you create a class, and there's this great book by Josh Blaylock, I think I mispronounced his name. Anyways, it's a great book by him, and it's about Java, and he talks about that when you create a class, you should create all classes to be APIs. So you're either going to make them to be extendable or you're not. And if you're not going to make them to be extendable, then you put final on them, meaning that whoever uses the class that you create won't be able to extend it. Now, it's only 5 characters, final, and so someone along in the future could come along and say, you know, why did he make it final? I can't reuse this class. They can change it at some point if they need to. But the whole idea is you either make it extendable or you don't. All right, let's go on. In your slides, there's another thing that you'll notice here, and it's called enumerations. And if we look at the enumerations, we're going to see that the months can be used as an enumeration. So I'm going to click into this real quick. And this is the month class. And you'll notice that the month class is declared public enum instead of public class. We've already talked about public interface briefly. We've done a lot with public class. This is the third type. It's called an enum. And enums are nothing more than just a list of objects. And they're great ways to define constants to be used in your applications. In fact, if you have constants that are used all over the place that need to be converted readily into strings, many times an enum is the best way to go. So here we have an enum of all of the months, and then they provide some other methods to define how to use those enums. Like they have a way of counting the months, of giving you the month in the order it's in. The enums, as you put them in, that's the order that they're arranged. Now you'll notice here, month is the integer that's passed in, and what are they doing? They're subtracting it from 1. So if I passed in a month of January, which is 1, they're subtracting from 1, and now they're making it 0. Why would they do that? Just to give you a foretaste, when you get into arrays and lists, the primary position for the first element in an array is position 0. So that's why they're subtracting, because they're saying, give me, out of this list of arrays, position 0, which is 1. So if I want a month for January and I pass in 1, which is what you would expect, they're going to give you the right month back. All right. Any questions about that topic? let's go on here. We've already done several date class examples. All right, we're going to move on to another example, and this is of composition. This gets into how we can use classes within classes. In Java, we often talk about inheritance and the relationship. So I am a child of my parent, right? And so it's appropriate for my parents to say, is a child. Michael is a child. Another relationship type is has a relationship, meaning food has a relationship to me. I eat it, right? Okay. So when we're talking about objects in general, we think about the relationships they have. Let's do a class example here of has a relationship. We'll just call this test composition, and we'll talk about the relationship of a class. So I'm gonna rename my class here. Jessa, could you shut that door for me? Thank you. Let's see here. There it is. I'm going to rename my class. I'm going to call it, for example, what we see in our PowerPoint slides. I'm going to call it school. Okay. And we'll hit enter. And it should change the name of the, yeah, there it is right there. And I'm just going to come down here. And I'm going to create some variables real quick. So this is a private name and address. And you'll notice that it says name and address. We can't resolve that. That's okay. We're going to define it as a nested class and use it as a topic of composition for composition. Okay. So then I'm going to say private int enrollment. And now I'm going to create my constructor, public school, and I'm going to bring in a string for name, string for the address, string for the let's see here, int for the zip, and int for enrolled. And just to make it simple, I'm going to say this enrollment equals enrolled, because this is a reference to the class, right? All right, but we need to create a class down here that will make this all easier to understand. So I'm going to create class name and address, curly bracket, and I'm going to create some private member variables, private string school name, private string, let's see, what do we need here? No, we need a zip code, right? Private int zip code, and private string mailing address. All right. So now I'm going to create a constructor inside of my nested class name and address. Public name and address. And let's see, I'm going to pass in a string for school name, I'm going to pass in a string for mail address and a int for zip code. Curly bracket, this dot mailing address equals mail address, this dot school name equals school name, this dot zip code equals zip code. All right. So now notice that the error message that IntelliJ was giving me has gone away. It's like, oh yeah, okay, we know what school address is because it's a nested class. We know it's nested because here are the curly brackets, right, for the school, and it's inside my class for curly brackets of the school. Now you can also put classes inside of a method, which makes it even more interesting, right? But the scope for that class is only usable inside the method because its scope is defined by where it exists. All right. So we'll come in here and we'll say name and address equals new name and address, and I need to give it a school name. So I'm going to pass in name. I need to give it a mailing address, so address, and I need to give it a zip code, so zip. Name parameter is being passed into the name parameter here, address to address, zip to zip, and so forth. All right, so I've created notionally this object. All right, so I've got my public static void main method down here. I'm going to instantiate my school class, and we'll call this MH Marianas High School, MHS, equals new school. All right, so now we need to give it a name. Marianas High School. We'll give it an address. I don't know what the address is there. 000 Beach Road. Quit. I hit something. Beach Road. And then the zip code, zip code, 96950. And the enrollment, we did a number, so let's say, how many are in Marianas High School? Does anyone know? 1,000? 2,000? All right, it's a good number. All right, so we got this. We've created it. And remember what I said, every object has an automatic toString method. So if I do this, system MHS, and I print it out, what do you think it's going to print? You guys have any idea? It won't be pretty. It'll print, but it won't be pretty. Because it's just going to print out the object reference in memory. Uh-oh. There we go. Did I miss any others? All right. So we'll print it again. And there's the toString. It's just a memory reference. That's all it is. It's not very useful though, is it? All right. So remember, everything extends automatically from object. I don't have to type that, but I can, right? It's not necessary. Every object, even string, extends from object. That's why they call it an object-oriented language. Except your primitives. Primitives don't extend from object, but that's It is what it is. All right, so let's add a toString method here. We'll say public string to string, and IntelliJ is going to give me this little message here, this object overrides statement. And typically when you're overriding a class, it's just a good idea to let everyone else know that you're overriding something. And so what you do is you put this at override, cancel, at override on the class. That just lets everybody else know, hey, he's overriding something from the parent. Now, that means that if I create another class and call it college, and I extend from school, I could override something in my college class, that one of the methods that exists down at the school level, right? So override, we're going to get into that later, but that's what it is. All right. I'm going to take this out, and I'm going to do cheat and do the easy method. Oops, cancel, not that one. And I'm going to override the toString because just about every IDE gives you this ability to override the toString because everyone wants to see naturally what the object is. And you just click on that and say OK. And notice what it's saying here, name and address. It's going to print the toString method of the name and address as well. But did I override anything in here? No. And because I didn't, when I run this, you're still going to see something that's kind of bizarre. You'll see a number for enrollment, and you'll see this weird notation, right? So there is name and address. It's still printing the memory location, but it is telling me more meaningful information. So I could go in here to the class again for this nested class, and where are you at? Generate toString. Okay. Now it's giving me more meaningful information. And I print it out again. There you go. I have more meaningful information, right? It's not the best printed format, but that's the purpose of that toString. All right, so this is a nested class. You guys see how the nested class works? You have the class, the subclass name and address that exist inside the school class. There's other types of nested classes as well. You can have a static member class. You could have a non-static member class, which is what this one is. You can have local classes and anonymous classes. And if you're curious about that, I'd like you to go ahead and write this reference down. This is the docs.oracle, and go to the section on nested classes. And this is the official documentation for Java, by the way. Everything you need to know exists here. They have it all. And Oracle, I believe, also has the Java doc, so we could go to the Java doc and see more. But you have nested classes, you have inner classes, local classes, anonymous classes, lambdas, and gives you reasons on how to use it. So again, this is up here in this area. Docs.oracle.com, Java SE Standard Edition is what it stands for. Tutorial, Java, so forth. I recommend you go there and read all that you can. Okay. We've covered quite a bit. What else do we need to talk about concerning objects for this week? Do we need to take a closer look at the assignments? Like, yes, Mr. Rogers, do my homework. That's what you're saying, right? No. Okay. Well, let's start one of your assignments, okay? And then we'll talk through the remaining part of it. All right, let me find it here. Has anyone started on the assignment for this week yet? Maybe? Because I'm looking at the submissions and I see 0 submissions so far. Okay, so let's do this one. I think this one probably is a little bit more difficult for you guys because you're looking at it going, what in the world? Overload methods? All right. So we're going to create a class called player health, right? And we're going to call it playerhealth.java. So we'll start up here. Player health. I'm going to override, refactor the main method and call it player health because we're going to put the public static void main method inside of it. All right. So I have my class with the public static void main method, right? It's called player health. It's playerhealth.java. And looking at the code requirement, I need to overload 3 methods. Calculate hit points. Okay. So 3 overloaded methods. So let's make it easier on ourselves. Copy. And we're going to say public void calculate. Like that, right? If you in your code, you decide to do it as a static, you can do it as a static and just call everything from within the public static void main method. But for purposes of practicing instantiating objects, I recommend going ahead and, don't make everything static. All right, so your first one is receives a single parameter. It represents the hit point, the cost of a hand strike. All right, for me, I'm going to do this like this. Actually, let me back up here. Take that out. And hand strike. And I'm going to do this. You notice that when I did this in IntelliJ, it automatically created that, right? This is so I don't have to keep going back and forth. This is up to you. You don't have to do this, but for me, it just makes it easier to read while I work. All right, so I'm going to calculate the points. I need a total health, right? So public, no. Private total health. And based on the algorithm, that should be a double. Double total health. And this needs to be set to 200 from what I understand, right? Okay. So when someone receives a hand strike, the number think I already wrote this in code that's understandable. There we go. Look at that. Right? And then I need to display the remaining health to the player. All right, so if I'm going to create a method, if I'm going to display the health all the time, I'm going to create a method for it. Public void display health. And let's see here. System out print line. Players total health is now that makes sense. So we could test our code. It's always a good idea to test as you go. So player health calculate hit points, and I'm going to give it a hand strike of a 5. And let's see, we need to do one other thing, right? We need to display health after we do the call. All right, so I do that. And we run it. Player's total health is now negative 191, but they've been destroyed. All right, so what did we do wrong there? Let's look at our math. So probably we need to move total health over here, right? Take this, move it to right there. Minus? Okay. All right, so then we run it. And now our player's total health is 191. All right, cool. So if I do another health dot calculate hit points, and I make this one a 77, you can see now it's decrementing down like we wanted it to. Right? Does that make sense? Okay. So that's calculating a hit point with a hand strike. All right. Let's go back to our code. Next one, when it receives 2 parameters. All right. So I'm going to copy this code just because you guys don't have to do what I'm doing, okay? I copy the directions because it makes it easier for me not to keep flipping back and forth when I'm thinking. All right. And by the way, if you double click on your tab up here, it will maximize the screen. You can click on it back and okay. So public void calculate hit points int hand strike int, what was the other one? Sword. Okay, hit point cost of 1 sword. So when calculate points receives 2 parameters, this represents the hit point cost of 1 sword strike. So parameter 1 is the point level of the hand. Parameter 2 is the point level of the sword. Okay? And then I've got my algorithm here again. But we already know there's a problem with it, right? So we got to move it over here. Total health minus, and change that and that. Semicolon at the end, and I'm going to display health. Okay, so this might be a good spot to think about what type of sword hits I want, right? So how about I have a public static final int, and I call this a broad sword. I'll know you copied, by the way, if you put broadsword. You're like, oh, really? You okay? I don't know what. So broadsword maybe has a 25 point hit. Let's see. What's another one we could create? Give me a sword, you guys. A what? A claymore? All right. An iron sword. All right, so this is, it's not very fun right now. What's it between a claymore and a broadsword? I don't even know what a claymore is. I'll make it powerful though. And an iron sword, let's make.
Claymore is like it's double-handed.
Okay.
And it's bigger than an iron sword.
Okay. All right. And someone else said, what did they say? A hand axe? An axe? Okay. Is that too low of a strike for an axe? Yeah. It's we're just playing around with the code, so just the idea, of course, is to when you run the program to see how quick you can kill your player. Make this one 199. All right. It's up to you. Let's just do something simple like 70 or something. All right. So we got some different broadswords or swords in general. So let's come down here and we will test our calculate hit point method. We're overloading it. So let's make our hand strike this time maybe only 4. And the sword strike, well, now we have a lot of different sword strikes. So let's do a broadsword. And let's run it. And boy, we did some damage, didn't we? So let's look at our calculation again. What did we... Oh, down here. See that? I'm subtracting it twice. All right, so let's run it again. There we go. Still alive. All right, so let's, we created some other swords. So let's, oops. Let's make this one, what do you want to make this one? Since we've created one up the top. An axe.
I guess.
And this one's a claymore. Let's make the first one an iron sword. All right. Okay. So we run it. Look at that. Total health is now down to 12. Yeah. And of course, you know, your hand strikes, maybe you want to call your hand strikes something. Maybe you want to create a hand strike and call it, let's just copy this just for fun. And we'll call this hand strike a Kung Fu Kill Ya. I have no idea what kind of hand strikes you guys could come up with. What did you saw? This one's called a Hacha. A Mr. Miyagi. Oh, that's a good one. You're all laughing. I say it again. Miyagaga. Miyagi.
Without the A.
This A or that A?
The one next to the I.
That A. That one? All right, that'll work. All right, so we'll make this one a A Mr. Miyagi. And he's dead. We've put him in the ground. All right, so you get the idea. Now you got to create your third calculate hit point. And I can't do that for you. Because that would just be like too much, right? Okay, so you guys got to do your third one. And work on the calculation. You could create as many spells or whatever you want to make it. Does that help now to understand what you got to do? All right, we got 2 minutes. What's the other homework assignment? The other one is, this is just simply a class with constructors. This is all it is. Okay, it's just a class with constructors. And you probably would want to make the Middle Earth characters private static variables, right? So make them private static variables. And yeah, it's very straightforward. So you're, let's see. Let me edit this last part though for you, because right now I don't want you creating multiple classes. Even though it would be a good idea for you to create nested classes and then, but for right now, let's just take out the, so you got a class name called ME Player, and you're going to save it, save the application. So you create the application called Test ME Player. You're going to save it as ME Player, but there you go. Does that make sense? So when you create the class, right, you're going to go into IntelliJ and you're going to create a so you create class called test project, no caps, test ME player. That's your project name. Okay? Make your main class ME player. That's what you guys need to do. Okay? And then the rest of it is just practicing doing the constructors and the methods. Read the directions though and follow through with it. Okay. I'll be here for a couple more minutes. If you have any more questions, other than that, you guys have a good weekend. Monday, do you all have class on Monday? So you guys, I won't see you till Tuesday anyways, but enjoy your weekend, and this should be pretty straightforward to you. The assignment is not that difficult. Okay. All right. Have a good weekend.